Hey guys, hope you're doing well, right? Right now, we're in the math competitions and I couldn't be with you guys, but I still love this video because that's the teacher that I am, and I'm so sorry we cannot have free time. But next week, we're gonna have movie week. So at least please watch this whole video. Please watch the video. It's gonna do you good. It's gonna be doing you good for the home test that you're gonna have soon. So today's topic is gonna be, it's not gonna be here. Today's topic, let me just share the screen real quick. Go. Okay. So, time to connect. There you go. So today's topic is gonna be extrema and end behavior. You know that in our last class, we were speaking about point symmetry and line symmetry, right? That if both graphs went up like this, that means that it has line symmetry. And if they go on a 180 degrees rotation, that's point symmetry. So now we're going to be describing extrema and end behavior. And for this, we're going to be using the term of infinity. Yeah, we're going to be using infinity. We're going to be using this symbol right here. Yes, infinity. And you know what's infinity, right? So infinity is just basically the term when it's going to go infinite into positive direction or a negative direction. Okay, so now with this topic, we're just going to be discussing that. Now, let's start over here. End behavior is the behavior of a graph as x approaches positive or negative infinity. At the right end, the values of x are increasing toward infinity, and this is denoted as x tends to positive infinity, okay? So this symbol right here means that x tends to positive infinity. As the left end, the values x are decreasing towards a negative infinity, and it's denoted as x is going towards a negative infinity. Okay, now for the graphs shown below, as x tends to positive infinity, f of x, remember that f of x is the same as y, f of x increases. So if y tends to positive infinity and x tends to negative infinity, f of x decreases, so f of x equals tends to negative infinity. I'm just going to explain this with the graphs. These graphs all have the same end behavior. Why? Look at this. If we draw a line, right? Let's do a blue line because there's already a red one. If you're going to get the end behavior, for example, when x tends to positive infinity, that's right side, okay? This is positive infinity, negative infinity, negative infinity. So when x, we're speaking about x, when x tends to positive infinity, y also tends to positive infinity. Also in this one, look, when x tends to positive infinity, y is also going to positive infinity. And this one right here also tends to the same problem. When x tends to positive infinity, y also goes to positive infinity. Okay, so all of these end behaviors are exactly the same. Now, look at this one. Describe the end behavior of each line function graph. So this one's a little bit different, right? Because in this one, when we go from left to right, when x tends to positive infinity is over here, right? When x tends to positive infinity, y is going downward. So y is now going to negative infinity. That's what's happening now, right? The x, when it tends to positive infinity, y is going to negative infinity. And when x goes to negative infinity, that's the right side, y is going up. So it's going positive infinity. Okay, that's the very big difference between the end behaviors. Okay, that's how you can do it this way. When x tends to positive infinity, f of x tends to negative infinity. And when x tends to negative infinity, f of x tends to positive infinity. So this is going to be the end behavior for the graph, the end behavior of both sides of the graph. Now, in letter B, this one, we have a horizontal line. So what we're doing here is exactly the same. Study the behavior on the right. Here we have a horizontal line. When we have a horizontal line, that means that the slope is 0. So what we're going to do is that we're going to go from left to right, right? When x goes to positive infinity, g of x only stays at 4. It doesn't go to positive infinity. It stays at a constant value, and that constant value is 4. And when x goes to negative infinity, it still stays at 4. So it will still be 4 at the constant value. Okay? That's the primary example of all of this. Now look at these two. Look at this guided practice. If you want, you can pause. You can pause the video right here, or you can follow along and you can do it with me. Now, if it goes from left to right, okay, the end behavior is as follows. When x tends to positive infinity, f of x also tends to positive infinity. That's why when we do the line, when you go to positive infinity, that's on the right side, y is also going up. So y is also positive infinity. And when x tends to negative infinity, f of x also tends to negative infinity because it's going downwards. Because when x tends to negative infinity, y is also going to negative infinity. That's how this will be your answer. This is how I want you to write your answers, okay? This is just telling you where the solutions are, okay? So if x tends to positive infinity, y tends to positive infinity. Now, in 1b, this is exactly like we learned before. When x tends to positive infinity, f of x tends to -3. This is -3. And if x tends to negative infinity, f of x also tends to -3. So this will be your final answer, and this will also be your final answer. Okay, that will be both of your answers. That's how you do it. That's literally all you have to do. Now, in this one, to determine the aim behavior, you do not need to consider the values of the graph. You just need to consider where is the graph going. Like, for example, in this one, look at this one. This one a little bit harder, but just bear with me. When x goes to positive infinity, right? Remember, this is positive infinity, negative infinity, and negative infinity. When x goes to positive infinity, where's the y going? Oh, it's going directly at negative infinity. So y is going, or f of x, is going to negative infinity. And if x tends to negative infinity, f of x is also leaning to negative infinity. Because when x goes to negative infinity, where's the y going? Down. So down is the negative infinity. Okay, that's how we're going to be looking for the solutions. Now look at this one. This is positive infinity, negative infinity, negative infinity. So when x tends to positive infinity is to the right. Where's the y going? Where is it going? Downwards, right? So this would be f of x, negative infinity. But when x tends to negative infinity, f of x is going to positive infinity, because when it goes to negative, where's the y going? Positive. So when x tends to negative infinity, f of x will tend to positive infinity. Okay, so yeah, that will be with this extrema end behavior. Okay, so this is gonna be your solution. This is your solution, and this is your solution. There we go. Now look at this practice. You can stop the video here so you can do the guided practice, or you can come with me and do it together. When x tends to positive infinity, f of x is also leaning to positive infinity. And when x tends to negative infinity, f of x is also leaning to positive infinity, okay? Because when it goes to positive infinity, remember this is negative infinity, positive infinity, negative infinity, positive infinity. So when x goes to positive infinity, y is going up. And then when it's going to negative infinity, y is also going up. So both of them, the end behavior is going to be positive infinity. For this one, when x tends to positive infinity, y, or f of x, is also going to positive infinity. And when x tends to negative infinity, f of x is also going to negative infinity. Going up, and this one's going down. That's how infinities work, and that's literally all you have to do. That's all you have to do. That's how you describe the end behavior. Now, in these, we have extrema of functions, okay? Sometimes the behavior of a function closer to the origin is important to know. The graph below shows a nonlinear function with coordinates close to the origin. Now, this is so easy. Guys, this is so easy. Look, relative maximum, right? Relative maximum means the highest point of the graph, and relative minimum means the lowest point of the graph. So in this case, if it's relative maximum, this is relative maximum, and this is relative minimum. That's all you have to do. And relative maximum and minimum are with the y coordinate, okay? Not with the x coordinate, the y coordinate. So this is only with the y coordinate. Now, the relative maxima and relative minima are often referred to as turning points, or the points where a curve completely changes direction from either down to up or up to down. So the turning point is exactly this, when it turns from down to up or up to down. This will be your turning point. And the turning points are known as extremas in the graph because they're going to be the extreme values of the graph. Okay, you're not going to be getting into this like real like into it. I just want you to know what's relative maximum and minimum. Maximum is the highest point and minimum is the lowest point. That's all you have to know. Now in this one, the table of values, okay? The table of values says R of a function with extrema. Estimate the zeros, then estimate the values of x which relative maximum or minimum occur. So this is easy. Where's relative maximum? Okay, relative maximum is right here. This is relative maximum. And relative minimum are these, this one and this one. So the relative maximum, you don't need to know this, by the way. This, I don't want you to know this. I just want you to identify which is the relative maximum and relative minimum. So relative maximum, max, is y equals 1, 2, 3, 3, like 3.2. So y equals 3.2, and minimum, relative minimum, is y equals like 2.8, and y equals negative 1, 2, 3, negative 4. These values, okay? These both are relative maximum and relative minimum. These two. Okay? These two. Minimum, maximum. This one, I'm not gonna ask you to do this. No, this is not at all important. Zero important in this one. And this one, tampoco. This is not important. Is this important? No, not important at all. So what I want you to do now, I'm still gonna give you this in paper because you guys, I want you to do it neatly, but I want you to do this part and yeah, only that part. The other part, I'm just gonna also add it into your worksheet that you're gonna do today in class, okay? And please remember that your teacher, your assigned substitute teacher needs to sign it, okay? He needs to, or she needs to sign it. Okay, so that will be all for today. Remember the home test, I'm gonna give it to you on Friday. And if you have any questions, please reach out. Please reach out, okay, guys? I do love you indeed. I love you all. And right now I'm with the math nerds in the math league. Pretty bitchless, yeah, pretty funny. But we're gonna win this thing because we're math people and math is good. Math is fun. So now have a great day, guys. Love you, miss you. Hope you're doing good and have a good day. I don't know how to stop this.